Yo, yo intento.
Yep. All right. Hi, everyone. Welcome. Good morning. Welcome to the first day of the Singapore FinTech Festival. Happy Monday morning. Hopefully, you're having a good start to the Singapore FinTech Festival. My name is Shantanu Dutt, and I'm the head of technology for Southeast Asia. I've had the privilege of working at AWS for a little over 9.5 years. My Twitter handle is sort of right there on the slide. So if you want to connect after this session offline on comments or things that you liked about my session, happy to connect with you on Twitter. I'm also joined with my colleague, Neja, who's going to be a co-presenter in the later half of the presentation today. So with that, let's get started. What we thought we will do is this is primarily meant for a developer audience. And what we were told was our developers joining this SFF festival wanted to look at certain learnings from the space. And what we thought we will do is uh, take you through a quick snapshot of how Amazon engineering, that is AWS and Amazon engineering, our service teams, how they operate and how they work. What's sort of the culture in those teams? How do they make technology decisions and how do they innovate? Obviously, this with the in the interest of time, this is not a completely exhaustive presentation. If you're sort of interested to do one for your own team or your own organization in the future, more than happy to do that. So it's sort of a shortened form. I was presenting about half an hour ago on another session to CXOs about innovation. And this is the formula I showed them. And what I covered in the other session was more of the mechanisms and culture in Amazon that really play a part in our innovation. And what I also said there is if you're interested to know how the other two components play out, which is our organization structure in our service teams and architecture, which is our microsystems, our microservices culture, and our systems, etc., that will be covered in this session. So those are things that we'll cover primarily in this session, which is how we are organized as an organization in terms of our service teams and engineering teams as developers, because that we think is a large part of our reason for innovation and our microservices culture, which is our systems and architecture. Now, this sorry, oops, yeah. Now, what we this came about many years ago, which is basically an anecdote from our leader Jeff. This is about 20 years ago, where he envisioned this concept that no single team can be larger than a certain size. And this is a concept that we have just taken aboard, absorbed, and then applied it to all separate, different teams at Amazon. And the reason for that, why we did that, is we figured many, many years ago that if a team gets too big and too large, then consensus making becomes a problem. Innovation slows down. There's too much bureaucracy, and so on and so forth. And so, even if there's a requirement for a particular product or a particular service for a large team, because the scale of that service has increased, we try and divide the team into smaller parts and divide the product into smaller parts. And this is a philosophy we have followed in our service teams, our fulfillment centers and warehouses, as well as our field teams and sales teams and solution architects. And the advantages of this model far, far outweigh some of the disadvantages. And we actually look to hire people, specifically whom we can trust. The decision making happens independently. Each of the two pizza teams actually directly speak to customers and are basically responsible for the end-to-end journey of the product. So there's no separate operational team that actually looks at the product. The same team builds it and then actually manages it. And if something goes wrong in production, they basically have their own pages going off during the night for them to actually build it. And the beauty of the way we organize them inside Amazon is they are pretty flexible, right? And so when I joined 9.5 years ago, the EC2 product, which is our basic unit of our service, which is a virtual machine on the cloud, that team had about 4 or 5 product managers. Today, that same team has 35 plus product managers because that same product has grown exponentially larger. And each of those teams with those product managers actually operate completely independently. So we are constantly chopping and changing, which means certain features of the product, the way it's monitored, the way storage works, and so on and so forth, are actually looked at differently. The inputs that go into each of those different parts of those products actually occur differently, and the feature releases, etc., are sometimes staggered, right? And so depending on the needs, etc., some of these teams are reorganized into larger or smaller teams at a moment's notice, depending on how the product and the life cycle of the journey works. And it's not necessarily putting specialist essays or specialist product teams into a product. It's also about putting generalists, and depending on what we are launching and what we're working on with constant changing requirements, the skill sets of those teams actually keep changing. So for example, we have announced that on the cloud, we are launching a data center or a region in Jakarta in Indonesia in H2 of 2021. The way that cross-functional team will work is a team responsible for launching Indonesia might have a team which might have a data center team and a infrastructure team, a software developer team, a microservices team, and a project manager, etc. All of them reporting to a single-threaded leader, and they all work together in the changing requirements of the project, that is basically in this case a region or a data center launch, might mean the different skill sets required for each of these engineers might change over time. So it's not that we look for different specialist engineers from a centralized function. We all actually organize them in common teams, and the learning path for each of these teams are changing. And as I said before, this concept of two-piece team does not really apply only to service teams. It's actually become so pervasive and so successful that we have applied to many, many different parts of our business, including our fulfillment centers. Our average Amazon.com fulfillment center has, and this is a picture of a 9th-generation fulfillment center, which is not the largest, but one of the larger ones in the US. And it has an ability to actually ship out 1 million products in a 24-hour period. Yes, 1 million units, plus minus 5%, depending on the size of the units. And the reason why we can do that is primarily twofold. One is use of a lot of robotics, which uses a lot of machine learning, by the way, by AWS RoboMaker, which is not part of this session. And the second part of the reason why we are successful is our org structure again, which is we are also divided in our two-piece team construct in our fulfillment centers, both in the front end in terms of employees working in different parts of the FCs. So a large FC or a large warehouse, which is the size of 10 football fields potentially, can be divided into hundreds of different parts, and each one of those parts actually in white circles operate completely independently, right? And there is a separate two-piece team manning each of those parts. So there's one small team doing shipping, the one small team doing packaging, one small team taking orders from robots, another small team basically putting a shipping label manifest, depending on which third-party provider, shipping provider this package will take a route of, and so on and so forth. And each one of those teams operate like an API. They don't talk to each other. So much so, there's a separate backend team in certain large-scale operations, which is a developer team that basically has and treats it like a microservice, so that if there are defects like a shipping taking too long, something that broke, or an employee of the fulfillment center taking too long to find the product that was ordered by an online shopper, there's a service team or a microservices team in the back end that looks at that data, because we do use a lot of technology in our fulfillment centers, treats that as a defect, and then works backwards to see how some of those defects can be improved. Now, are there cons to this model, of this operating model, the two-piece team model? Yes, there are. And one of them that we figured about a few years ago was that as we were actually expanding our products and applying this to various parts of our business, we actually ended up having too many two-piece teams. Because under a common product, we had too many two-piece teams, which means the weekly sprints and the reviews became very difficult to review. Because how do you actually encourage a culture that is not too bureaucratic in a company like Amazon, encourages experimentation, but you also need to keep checks and balances in play by reviewing the progress of each team. And then what we thought of was we cannot surely go across every single team and reviewing every single two-pizza team because there are way too many teams. It will add a layer of bureaucracy. It will just make it too cumbersome to go through every single team every single week. And so someone actually came up with the idea, our SVP Charlie Bell, with this idea of the wheel of death. He called it the wheel of death. It sounded scary. I like to call it the spinning wheel because it's much more subtle. But the wheel of death was this concept where the name of every single two-pizza team basically was put up on a wheel, a physical wheel. And on a Wednesday morning, all the teams under a common VP's set of products or services used to accumulate in a hall. They used to all gather there. And then someone used to come ahead and then rotate this wheel with his or her hand manually, and the wheel used to go round. And then after a while, it used to come to a stop. And if you see the maroon color arrow on the top, basically it's like a roulette wheel. So wherever the wheel stopped and the arrow pointed towards, that team had to step up and give their update for the week. And the bar is really high. So if your update of the week was not up to the mark, then it was a cross against your team. And 3 crosses is an anti-Jassy, CEO escalation, and so on and so forth. So every team, knowing what was at stake, used to come absolutely prepared and be at their toes. But this mechanism also meant that we did not go through every single team. We did it 3 or 4 times or 5 times, and then everyone used to disperse and go back to their work. This meant that every single team used to come prepared, and there was sort of a checks and balances in place indirectly, but we need not go through every single team as a result of this mechanism. Guess what happened after a few years? The number of teams became too many to the point where this wheel could not accommodate all the teams. And so we then switched to virtual, wherein we got a laptop, we built a wheel of death, which was a software version, and then the wheel basically had names of all the teams. And the beauty of the software is you can tweak it. So we basically infused with machine learning various rules in place where a team that got a chance in early January would ensure that they would get a chance again sometime throughout the year, simply because we didn't want that team to rest on the laurels, right? And so we built in all these rules to build in randomization. Because it was machine learning software enabled, we could tweak things versus the manual wheel. And it could scale no matter how many teams because it was based on software. It became so popular with our customers as well that now we have actually open sourced the wheel. So if you go to that blog post, the link that I've shared with you, you can actually implement the same wheel of death in because we have open sourced it in your organization if you want to sort of follow the two-pizza construct and follow this mechanism. The second thing I want to cover quickly is how does Amazon make technology decisions? And it's easier than you think, but it's also more difficult than you think because we actually based our decisions on certain lessons learned over the years. And with AWS specifically, there are about 10 to 12 lessons that we learned in our initial 10 years, and I'll just cover 4 or 5 of them. The first time, if everyone could unmute their button, I would have asked this question, but you can't. But I asked the question as to any guesses what this is. But this is a date when we released our first ever service in a public fashion, which is in the form of simple service storage, which is S3. So this is our first ever product, our first ever service released publicly. Remember, this is a time when public cloud or cloud as a term did not really exist in anyone's dictionary, right? The pay-per-use concept did not exist. So we literally invented this and we didn't know what to expect. And there were a lot of lessons we learned on the way. The first one is that when you're developing a product, build evolvable systems. Do not get stuck on frameworks. Primitives are greater than frameworks. And what we mean by that is build primitives. So it's almost as if you build a lay of land, build a building as a constructor, as a developer, but do not build each apartment exactly the same. Let the tenants coming into that building figure out where the kitchen will be, where their sink will be, where the bedrooms will be, etc., because they are customers and they deserve that right. And so if you actually build a framework, then it becomes too rigid. It doesn't become evolvable over time. And that's the first lesson we learned. And at Amazon, what we did was we basically first built APIs. So had APIs exposed to customers to actually turn into S3 in the way that they wanted to. Then based on customer feedback, we switched to having SDKs in different languages. Then we got our console and then we got our CLI, right? And so based on customers and the feedback
The
they
first
were getting,
casualty of SFF is Kelvin. But people do not hear. No voice.
oops, guys, can you unmute mute your lines? The oxygen team, can you mute your
Captain was
lines?
saying something. His audio was not. I think somewhere.
Hello. Looks like someone has unmuted a line. Can someone mute your line, please? Yeah. Okay, thank you. And so the first lesson we learned is building evolvable systems and not really get rigid with frameworks. And as one of our senior VP and distinguished engineers in Amazon put it, the first version of our simple storage service, which was a storage service in the cloud, was almost equated to a single engine Cessna plane, which is basically passengers inside the plane sitting in, looking at the blue sky. So they were our S3 customers. But as they were flying, we were basically refueling that plane in midair and then changing the engines and putting in more engines and more capacity. But for the customer and the passenger in the plane, it was just the blue sky as if they were flying. There was no change at all. And over time, over many years, we were adding more APIs, SDKs on the external. To the customers, they got various interfaces. The plane started changing to a A320, to fleet of jumbo A380s. But for the passenger and the customer, the S3 interface remained the same. We were just adding more interfaces. To the point where today, S3 basically can have at its peak trillions and trillions of objects and millions of requests per second coming into their backplane. But in the beginning, 14 and a half years ago, it was very minuscule. The scale was nowhere here. But we wouldn't have reached this scale had we not built evolvable systems by just getting stuck with frameworks, because every single time we would have to rebuild it all over again, which means it wouldn't have been scalable. Lesson number 2 that we learned was expect the unexpected. As the Werner Vogel's, our CTO's anecdote goes, that everything fails all the time. And as a developer, build systems that don't have a single point of failure. I find it still funny when I have conversations with CIOs and CTOs as well, that they put an inordinate amount of effort and questions around what is the SLA. What is your Amazon SLA on the cloud? Yes, we do have SLAs about our services, but the point is that cannot be narrowed down to a particular service at a particular unit, because hardware and software will fail no matter what the SLA. The SLA that your vendor gives you has got nothing to do with actual uptime, right? Period. What it does is just a financial construct. And so what we tell our customers is build applications and architectures that do not have single points of failure. And in the cloud, you can build it more easily across highly available systems, across data centers, even in some cases across regions, across continents, so that when a particular part of a system fails, it doesn't really matter, because in a microservices environment, a single point of failure does not exist. And so expect the failures all the time. We learned it the hard way. And today we have a completely microservices, thousands of microservices powering our Amazon.com website and our AWS website. The third lesson was having an API. That's just a culture coming in from Amazon.com that we always had. But for a B2B business like AWS, we realized it early in our days that no matter what we are building, a dev test system even, we have to have APIs, and we have to invest a lot in our APIs, because you never know. In the future, everything basically talks to everything in Amazon in APIs. And for us, the way we see it is a product without APIs is like a smartphone without internet, period. Like within Amazon, if you actually build a product without an API, without the construct of an org structure that I mentioned to you, your product will be shed apart to pieces. It will never make it past a certain stage, simply because that's just a culture that you have developed with. Moving fast for the remaining two, because these are easy. We believe automation is the key. Now, yes, a lot of companies have developers in the DevOps construct, and we believe there is automation. But true automation, according to us, like a litmus test of automation, is if you have Linux systems, for example, in your organization, and you still have to do SSH into those systems to do troubleshooting or to do patch updates, etc., then you should know that there's still scope for actually automation. And according to us, automation, to us, the litmus test is that you don't have to log in or even SSH to a Linux system frequently, because that should be able to be done with regular scripts and regular updates in your systems. So we spoke about, org structure, and we spoke about lessons learned in terms of technology. The third part is how do we iterate at speed? And I was speaking about this in our last session, that the frequency at which Amazon.com, the mothership, applies software updates on certain days is once every 6.6 seconds. And a large part of that is our organization structure. But what goes in hand with that is our microservices principles that work into play. So this is something that we did not achieve on day one. Amazon.com in the early 2000s was really like any other startup. And our systems were not as sophisticated. And over time, what we actually got into was bottlenecks of having a monolith architecture. So much so that we used to call our first system as Obidos. Now, Obidos, coincidentally and ironically, was the narrowest part of Amazon River in Brazil, where it was basically a choke point. So Obidos is basically the place where the river basically meets into a choke point. It's a very, very narrow stretch. We did not know that. We just named it Obidos many years ago. And this name became foreshadowing of our monolith culture. Obidos was a system which basically had the shopping cart, the order management system, the analytics system, the pricing, everything basically built into one system, which means anytime we had to upgrade one system, the entire system had to be upgraded. And over time, basically, we finally in 2002, 2003, started applying a microservices culture. We started to build AWS internally as an infrastructure platform with web services. But we did not achieve it overnight. What we started doing is, rather than actually going from monolith to basically completely microservices, we started taking it bit by bit, which is basically taking each part of the system and making it into a separate monolith, with basically having a separate ordering system, separate cataloging system, separate finance system, etc. But what ended up also happening was each of these systems became a monolith, a smaller monolith of its own, which is fine. So for example, in some cases, we were more urgent in changing the microservices dynamic. For example, the perfect example was ordering. Now, till about the Kindle came out in 2005, 2006, the ordering system in Amazon had to fulfill orders with an SLA of 1 day or 2 days or 3 days, because that's how online orders work with physical books, for example. As soon as the Kindle got invented, the order management system had to take into account that books online in the Kindle, the digital books, had to be fulfilled in 30 seconds. And so we basically had to tweak the order management system and had to actually port it to actually cater to those requirements for online book orders, physical books, and digital books, and so on and so forth. And so that's the way we started actually looking at each of the systems. And over time, each of those became monoliths. But over time, depending on the requirements and the urgency, we started creating microservices. And to the point where today, we really easily have hundreds and thousands of microservices. Every time you go in as a shopper, as an online shopper to Amazon.com, you might not realize this, but your request, as soon as you click an order to buy it, makes a request to hundreds and thousands of microservices in the background. In the order of, in the front end, it might have 200, 300 services. In the back end, it might have hundreds and thousands of microservices. And our philosophy is every single microservice is single purpose, single threaded, and highly decoupled. And so the blast radius of failure is very, very minimal. And the last piece before I hand it over to Nirja is one thing that we've learned, job zero in Amazon is security and operational excellence. In case we find anything remotely even wrong with our security and operation excellence, we ditch everything else and we focus on those, right? It doesn't matter with the short term, we might withdraw a product and we might lose some revenue, but security and operational excellence is just a core DNA at Amazon. And the operational metrics, the way we actually do troubleshooting, the way we actually have dashboards is something we put an inordinate amount of effort into intentionally, because that's job zero for us. And a lot of customers ask us, like, how does Amazon track metrics and what are metrics that you track on, right? And so what we tell customers is we basically in the back end actually divide metrics, our health metrics, into two parts. One is health and one is diagnostic, right? And we distinctly distinguish between these two. Health metrics is something failing? That's the first thing we try to address. And then In the later half of that troubleshooting scenario, we look at diagnostic metrics as to why is that not working? What's the root cause? And so if you look at, if you're a developer, if you look at historically, 5xx metrics, right? 500 errors or 500 errors. The way you measure SLA is you look at the number of 500 errors divided by the total number of request count, and that's your SLA, right? So 99 point whatever percent. And so 5xx errors indicates a problem, and that's typically a health metric. Like that is a problem. Whereas a 4xx error could be a health metric, or in some cases could be a diagnostic metric, right? So you could have a case where a security certificate is expired and failing in a load balancer, and that could have a trigger effect on breaking an authentication mechanism to servers. So you might have 5xx errors requests that don't reach the server, but there'll be a spike of 4xx errors as well. And that's how we sort of divide that, and we have different 2 visa teams to address them, and that's how we put in SLAs. The other thing that we do, and this is obvious, but we do this much more meticulously, is we go right up to the 99th percentile or even more in certain cases. So we look at averages, we look at 50th percentile, but we also look at 99th percentile. And there's a reason for that. And depending on whether you're looking at actual data, so customer hits coming in, or you're looking at control plane, right? So your actual service control plane, depending on the volume, we measure 99th percentile or 50th percentile. If it's just control plane, which is a service mechanism where just looking at the health of the service, then you could look up to 50th percentile in terms of monitoring. If you're looking at volume of hits coming in, like the actual data, then 99th percentile is important. And why that is important is, we have a culture at Amazon of data. If you have data, and this is true in business as well, if you have a meeting going on in Amazon and you have argument going on in a meeting room, there is no concept in Amazon of seniority or tenure. If someone is more senior or more tenured in Amazon, that means nothing. What we look at is really data. Anyone can prove an hypothesis with data, always wins, period. That's just a culture we have, and it also translates into technology. But sometimes we also have this saying that you also have customer anecdotes, because sometimes data does not really prove everything, and sometimes anecdotes and data conflict. And this came out many years ago where it was an anecdote from Jeff, where when data and anecdotes disagree, our experience show in the service teams that anecdotes are usually right. And this reminds me of a story about 15 years ago when the Amazon systems went as sophisticated. As the legend goes, apparently Jeff Bezos, our CEO and founder, walked into the Amazon office and basically said that, the Amazon.com website is not working. I mean, it's working slowly. Now, one thing that you might not know about Jeff is that Jeff happens to be one of the top online shoppers of Amazon. So he's a CEO and founder. He owns the company, but he incidentally also happens to be one of the largest shoppers of Amazon. So on the personal side, he basically orders everything from Amazon. So he's one of the top 1% of our online shoppers, incidentally. Now, what happened was Jeff basically came to office and said, something's not right. The Amazon.com website, the main page is loading slowly. There's a lot of latency. And so all the engineers basically started scrambling, because Jeff has told us that the Amazon.com website is running slowly. The latency surely is high. We need to scramble. And everyone started scrambling. And they looked at the dashboards, they looked at all the data and all the metrics, and they found out that, nothing's wrong. Like everything is working well. So like, what's the big deal? Jeff must be wrong. So they went back to Jeff and said, Jeff, everything is working well. Jeff said, no, look at your data. Something is not right. The latency of a website is high. And the engineers again went back and they found out that nothing is wrong. And before this went on for a couple of weeks before they found out, when Jeff sat with them and showed him that Jeff's account was running really slowly. But turns out that we were actually serving our biggest customers on the planet the slowest. And the reason for that was because our systems were not as sophisticated as then. Our biggest customers like Jeff had a long list of orders that they'd already ordered in the past. And that page, which basically shows the number of past orders, was basically creating a trigger effect where the page was loading slowly because the number of orders that the top customers had shopped for is inordinately long. And because the systems were not sophisticated, it didn't catch this. And so even looking at 70th or 90th or 91st percentile really didn't give us, because we thought that most customers, 98% of most customers on this planet, it's working well. And those remaining 1 or 2% of customers, we thought these could be customers with slow internet connections. So let's just disregard them. And so sometimes it turns out in the AWS world as well, we look at customers and customer anecdotes as well. And if it doesn't match with data and what we are seeing, we prioritize anecdotes over customers. And then lastly, from a dashboard perspective, what we look at with our developer team is we have a healthy layout of a great dashboard. We don't look at dashboards that are internal. We look at dashboards that our customers see. So we have a dashboard saying that this is what our customers are seeing. And so we actually poll our console to look at dashboards there. We also have a very simple dashboard for a leadership team, because when there are faults, we don't want to look through a complex set of dashboards. So what our leadership team sees is 3 dashboards: the number of volumes of requests or certain ups or certain downs, the total number of faults, and the total amount of latencies. Because from a leadership perspective, these are easier to see. And then for our service teams and our engineering teams, each of these dashboards have basically sub dashboards, which can be tens and tens of dashboards, so that they can actually troubleshoot. And at the high level, it's kept easy. That's it from me. I just wanted to sort of quickly do a high-level overview. Hope that was useful. I also have a demo to show with computer vision and sort of voice and cognitive services. But before that, let's hear from Neerja, my colleague, around some of the innovative use cases that our developers are, I guess, driving in the machine learning and analytics and cognitive services industry using cloud from the financial services industry. Neerja, over to you.
Thank you, Shantanu, for sharing the best practices from Amazon's engineering teams. We're going to switch gears a little bit here and take a look at real-world innovation stories from financial services. Can you see my screen well? All right. Yeah. Sorry for the fumble. I hope everybody can see my screen now. So I'm Neeraj Gokhale. I'm an industry specialist at Amazon Web Services. And in my role, I'm fortunate to work with financial services customers of all shapes and sizes as I help them to innovate using AWS services created by the same awesome engineering teams that Shantanu was speaking about. At the beginning of his session, Shantanu laid this out as the equation of innovation at Amazon. We are going to spend the next few minutes listening to and walking through some of the customer stories who are realizing this equation in real world, starting with the mechanisms, culture, and the org aspect. First, Shantanu emphasized the importance of enabling and empowering builders and giving them ownership of the systems that they are building. A number of financial services institutions and fintech alike have been empowering their builders using AWS training and certification resources and programs such as AWS Skills Guild. For instance, National Australia Bank, one of the largest banks in Australia, began this journey of builder empowerment in late 2018 through NAB Skills Guild. They were able to train 4,500 individuals with basic cloud skills, 900 out of whom went on to do an AWS certification. This investment actually paid off very, very well as these builders started innovating on behalf of their customers and launching innovative products into the market. One such innovation is a very NAB-specific, unique Australian voice, which was launched in February this year in all call centers of NAB. If you are a NAB consumer and give them a call, here is the voice you will hear.
Welcome to National Australia Bank. This is the new voice of NAB, created by Amazon Polly, a service that turns text into lifelike speech.
Now, builders at NAB actually worked with Amazon Polly teams to create this special voice using the band voice feature. The underlying technology is NTTS, Neural Text-to-Speech Technology, which also actually powers Amazon Alexa. Because of this voice, NAB is going to be able to give a very consistent customer experience in their call centers and create a brand association that's unparalleled. Now, moving on, WeLend, an online lender in Hong Kong, who went on to become a virtual bank, relies on a homegrown decision-making engine based on AI and ML called vDefend. VLab engineers actually use Amazon Recognition to differentiate between different types of documents being uploaded by their consumers during loan application process. For instance, they use Amazon Recognition to differentiate between a driver's license and a national ID card. VLab engineers also use Amazon Guard Duty for detection of threats. Now, with AI, ML, and logic already embedded in this service, VLab engineers were able to save 15% of the time they would have otherwise spent on monitoring, which freed them up to build what they do best, stuff like vDefend. VLab engineers actually subscribe to AWS online training talks and stay abreast with a free of cost resource to understand what's happening in AWS services. Now, when it comes to building a culture of innovation and having fun along the way, AWS Deep Racer League is an awesome mechanism. With AWS Deep Racer, developers of any skill level can actually get hands-on with machine learning. They can build models using SageMaker, try, fail fast, iterate, as Shantanu mentioned, using the 3D cloud-based simulator. GPS Bank early this year executed AWS Deep Racer League internally. As Piyush Gupta said, a bank which has actually won consecutively 3 years the Best Bank in the World award wants to accelerate their journey to innovation by embedding AI and ML. And in order to do that, they want a critical mass of their employees to be familiar with the basics of artificial intelligence and machine learning. So let's watch a small clip.
So when I first heard about it, my reaction was, wow, fantastic idea. AI and machine learning is a fairly abstract concept for most. And so through this exercise of gamification, it allows people to be very engaged, to say, hey, there's something that I can do to win. It is all about how can you train a model to help you to learn a lot faster, to allow us to experiment on the different hypotheses that we would have.
I realized that it was a very fun and easy way for anyone to get started with machine learning. So we brought this program together and rolled it out bank-wide, not just to techies, not just to the ground level people, but also to the executives and senior executives in the bank.
So
I decided to join the Deep Racer League training program because I was drawn into the hands-on aspect of the training, where I get to program an autonomous scaled-down vehicle using just a few lines of code. I really had fun in the program.
as you can see, when developers are well empowered with right training, skills, and resources, they have been innovating across all sorts of use cases in financial services, right from core processing all the way down to the customer experience and end user experience. And this pace of innovation has been accelerating across all segments of financial services, may it be anti-money laundering and compliance in banking, or underwriting in insurance, and from fraud detection in payments down to robot advisory and algorithm trading in capital market space. What I'm going to do on my next slide is going to walk you through just 3 of many examples that we have of innovation in financial services around us. Best to Credit is a fintech in India who actually have been able to bring down the loan processing time for small and medium businesses from 7 to 10 days to just 24 to 48 hours. They were able to do this by solving the main challenge in a typical loan approval process. More often than not, all the documents that are submitted by a small and medium business have different formats, but it's critical to extract important data points from these documents and analyze those data points in order to predict the seasonality of the cash flow of this SME business. Look at their expenses carefully and understand their real revenue potential before approving the loan. And that's the area document digitization and analysis is what slows down, because usually it involves a lot of manual effort. Biz2Credit used Amazon TechStrack to solve this problem. With use of Amazon TechStrack, when they served a large global bank, they were able to reduce the manual effort by as high as 80% and speed up the loan approval process. The next one, Jinja, is a born-in-the-cloud neobank in Australia. Jinja actually aims to provide very, very relevant and personalized products to their end consumers. In order to do that, they rely on AWS analytics services. They use AWS Athena, AWS Redshift, and they also use AWS QuickSight to maintain those dashboards which Shantanu was describing earlier on. Finally, Sunday Insurance. Sunday Insurance is a insurtech in Thailand who has been democratizing insurance by providing customized policy premiums, and one of their strengths is their AI/ML based policy pricing engine, which also runs on AWS. With that, I'm going to go next back to Shantanu, because he's going to show us how developers can actually realize this kind of innovation with just a few lines of code. Over to you, Shantanu.
All right, so just quickly before we end, let me see.
And move them to you. So you become the core, the traditional core SMB engaged account manager. Yeah, there's 3 layers here, right? Like traditional is like a given.
Okay, Nija, you want to mute your line?
Yeah.
That's fine.
Let's see if my screen, which part of my screen this is showing. Can someone confirm they can see the connect screen? But it's not the connect screen, the window on top. Let me see here.
Yeah, now we have the connect screen.
Okay. So what we'll show you guys is, we have a lot of financial service customers, especially banks or even fintechs, tell us in the past that, and their customers tell us in the past that one of the primary pain areas that they have is customer service, right? A age-old sort of problem that has already existed in the industry. And the reason why customer service is still difficult is because cognitive services or voice today in the industry is still important. It's much more easier for a customer to just call a call center or basically have a chat bot, voice, or speak to Alexa and do banking services. And the call center operations as a concept is not going away, not in this part of the world. And Amazon solved this problem many years ago with its inbuilt call center, machine learning enabled intelligent contact center. And what we did in 2016 was expose this to a slew of our customers as a common API as a service from AWS. Now let's look at how this works. We just recorded a live demo last week. It should be self-explanatory, and then I'll explain what this. Hopefully the voice works.
Basic queue.
Hi, John. I've been a customer for 2 years now, and I just received a notice that the special pricing I got when I first signed up is about to expire in 2 weeks. I called yesterday and I spoke to Steve, but unfortunately, he wasn't very much help. I checked your competitor's website and they are offering better pricing.
Now, what you saw here was just hypothetical customer calling in, an agent sitting in. But imagine if you were the agent, how intuitive this entire screen is, because things are being transcribed as the person is speaking. The key phrases are being underlined using NLP, or natural language processing technology. And so someone could actually read it fast and read between the lines. And then on the bottom of the screen, you'll be seeing basically a live translation into Mandarin. So someone that's not comfortable with English. And then on top, I don't know whether you guys noticed, this emoji and a customer sentiment tracker was changing live as the customer spoke. It started off with a neutral expression, then a happy expression, but suddenly it then went to this expression with a red sentiment for obvious reasons, because in this case, the customer is clearly not happy because of the pricing not being right for them. And more importantly, with the integration capabilities that Connect has, it basically is pulling out offers of loyalty and discounts and programs for this customer based on pricing, simply because the biggest, the biggest anecdote that this customer is given and why the customer is grumpy is basically pricing. And so before even an agent has started talking, that person has everything on his or her screen to basically start answering the questions in a much more intuitive manner and has all the tools, versus putting a customer on hold and then checking with his or her colleagues and other things, which is what usually happens in the contact center. And you can take this much, much further. You know, Globe Telecom, which is one of the largest telcos in Philippines with 65 million subscribers, has said at reInvent, their CIO mentioned this, that they have transitioned directly 100% of their call center operations to Connect, and their average call handling time, right, AHT, has reduced drastically. We have a couple of banks who have moved on this in ASEAN, whom I can't name right now because they're on an NDA, who have seen similar benefits as well. So with that, I will basically stop for 2 minutes. I know we are almost out of time, but happy to take questions if there are any. No questions so far? All right, there are no more questions. Thank you everyone for joining us. Hope this was useful, and have a good rest of the Singapore FinTech Festival. Bye.
Thank you. Bye-bye.
You define which ones are like L, medium, small, micro, zero.